Hey kids, Flexing Teacher Weber here. I hope you're having a good day. We have been studying proportional reasoning, and we have moved into a specific kind of proportional reasoning called rates. Now, a rate is a special ratio that compares two related quantities. We'll give some examples in a second. And what we're focusing on in this section is not just rates, but something called the unit rate, which is expressed as a quantity of 1. So for an example of a unit rate is in the 2009 World Track and Field Championships, Usain Bolt ran 44.72 kilometers per hour at his top speed. That kilometers per hour, km per 1 hour, since it's per 1, that's called a unit rate. So we use unit rates to make comparisons because it's easy to compare things that are out of the same amount. So that's what we're focusing on in this section is rates and unit rates. So we talked a little bit about some of the kinds of unit rates there are out there. You get a part-time job, you'll be concerned about dollars per hour. Driving on the highway, kilometers per hour. Running races, and with the Olympics right now, a lot of races are measured in meters per second. If you follow hockey, goals per game. We talked about heart rate, your heartbeats per minute. And what we actually did is the kids actually in class calculated their resting heart rate and determined if they had an appropriate resting heart rate. So your resting heart rate should be between 60 and 100 beats per minute. And what we actually did is we counted our number of beats in 30 seconds, and then we used a proportion, multiplied that by 2 to get our heart rate per minute or our unit rate. The other thing we did in class is we did some running races in class, and we calculated our meters per second. I had the kids running down the hallway. They ran about 40 meters down the hallway. We timed them, and then they figured out their unit rate in meters per second. So let's look at some examples of that. So here are some examples where we used a proportion to solve each problem. It says Jeremy runs 150 meters in 35 seconds and Jack runs 175 meters in 45 seconds. Calculate the unit rate for each guy. So what I'll do is I'll divide my page into Jeremy and Jack. And Jack. And the first thing I want to do is talk about what we're comparing in this question. Well, we're comparing distance to time, or meters per second. You could sort of classify it any way. I'm going to say we're comparing meters per second, which is distance to time. Typically, when you're including time in a ratio, it's usually included as the second part of the ratio. And Jeremy runs 150 meters in 35 seconds. And when we're calculating a unit rate, we want to know how much Jeremy runs per 1 second. Oh, and I made a little error here. There should be meters and seconds. So we want to calculate how far Jeremy runs per 1 second. So the thing we want to find out is his meters per second. So x is his meters. So we'll say let x equal meters. And then to figure out this solution, we solve the proportion. What do I do to 35 to get 1? Well, I divide by 35. And I would do the same thing to the top. 150 divide by 35. And when you work that out, you have to round it off, but you get x is equal to 4.29. And to write this properly as a unit rate, we would say 4.29 meters per second. And that's how we'd write that. And that's Jeremy's unit rate. Now, to do Jack's, we'd do the same thing. 175 meters, 45 seconds. This time, since it's a different person, we'll use a different variable for our unknown. We want to know how many meters he'll run per 1 second. So we'll let y equal the meters in this one. And then once again, what do I do to 45 to get 1? I divide by 45. I do the same thing to the top. 175 divide by 45. In this section, I will let the kids use technology. When you round this off, you get y is equal to 3.89. And to write this properly as a unit rate, we would say 3.89 meters per second. Now, Jeremy has the faster unit rate because he's covering more meters per second, but you also have to remember he was running a shorter distance. And of course, as you run farther, your speed is going to slow down, right? But in this particular question, Jeremy has the higher unit rate. Let's look at another one. So you might use this to calculate your wages at a job. It says Lily earns $78 for working 6 hours. Taryn earns $192.50 for working 14 hours. Find the unit rate and determine who has the better wage. Well, let's divide our page into Lily and Taryn. Okay, and we're comparing, in this question, we're comparing dollars per hour. Dollars and hours. Lily earns $78 for 6 hours. I'll shorten those up a bit in my ratio. And we want to figure out how many dollars she earns per 1 hour. So there's our proportion. So we will say, I didn't leave myself a lot of space, let X equal the dollars. And then same thing with Taryn. Taryn earns $192.50 over 14 hours. And we'll use a different variable for Taryn, y over 1. We want to know what she earns in 1 hour. So we'll let y equal her dollar amount. Now to solve these. To go from 6 to 1, I would divide by 6. Do the same thing to the top. So $78 divide by 6. And that's $13 exactly. So X is equal to 13. Now, if we're writing this as a unit rate, we would say $13. And even though there's no cents, we put 2 decimal places, $13/hour. That's her unit rate. Wasn't very neat though, let's fix that up. $13 per hour. Taryn's unit rate, to go from 14 to 1, I divide by 14. So I'll do the same thing to the top. I'll divide my top number of my proportion by 14. So $192.50 divide by 14. And I get Y is equal to $13.75. So as a unit rate, that's $13.75 per hour. Now that we have a unit rate, we can see who makes more money. Taryn has the higher wage. Period. So that's how we use unit rates. We use unit rates to make comparisons and to understand some data better, right? It's a lot easier to understand what's going on or what they're making at their job if you know their hourly wage. So I hope that helps with the assignment today. That's all for now. Flexing Teacher Weber, out.